The question asks us to determine the concentration of the potassium carbonate solution. To calculate the concentration of the solution, we can first use the data given to us, that is the concentration and volume of the acid, and use these to calculate the moles of acid that react. And then, from the moles of acid, we can find the moles of potassium carbonate that react. And then we can find the concentration of the potassium carbonate solution using its moles and its volume, which is the average titer. So we can start by taking the concentration times the volume of the acid, and we get 0.0025 moles of acid reacted. From the balanced equation stoichiometry, we can see that for every 2 moles of acid reacting, 1 mole of potassium carbonate reacts. And since 0.0025 moles of the acid reacts, we know that X, which is the moles of potassium carbonate that reacts, will be half. Solving for X, we get 0.00125 moles of potassium carbonate that reacts. All that is left to do is to use the moles of potassium carbonate and divide by the volume of the potassium carbonate solution to get its concentration. We know the mole value, we just calculated it. And the volume value is the average titer. Since there are 2 titer values, we can add them and divide by 2 to get the average titer, which is 20.1 centimeters cubed. And we must convert this to a value in decimeters cubed by dividing by 1000. So the average titer in decimeters cubed is 0.0201 decimeters cubed. Putting this value into the denominator and then solving, we get 0.0622 moles per decimeter cubed for the concentration of potassium carbonate.